So, equilibrium, chapter 13. So this is a lot like, okay. So, chemical equilibrium. So we learned kinetics, how fast a reaction goes. Equilibrium, it shows that a lot of chemical reactions don't just go forward, but they go backwards and forward. So the state where the concentrations of all reactants and products remain constant. So it's not like kinetics, equilibrium reactions going both ways. You're going to understand this. Third hour really picked this up quickly. So for example, here, and this is like a, somewhat of a, whatever, inspirational picture, if you want to say that. But anyways, notice how we have whitefish and blackfish over here. And all the whitefish and blackfish want to be of the same amount on both sides, right? So it's a good example. Anyways, so if I added, so this is at equilibrium, right? So blackfish are going one way, whitefish are going one way, but they stay at the same amount on both sides. Yeah.
These are wrong.
All right, thanks. No. All right, so simply enough, you start the fish off like this, it reaches chemical equilibrium. So let's say these are the products, and these are the reactants. But this is going back and forth. Fish are still swimming back and forth, right? Yeah. Now let's say if I added blackfish on this side, which way will the reaction go? This way, right? And so you'll see on the test, there's somewhat very simple questions that I did not get to teaching at Marshall, and I wish I did because it's something that I think they would have got. So if I added blackfish, the reaction would go away this way. If I took away blackfish on this side, the reaction will then
come back the other way.
Right, go this way. Does that make sense? Mm-hmm. All right. So just like here, this one blackfish is going to be swimming back and forth. And just like the whitefish will be swimming back and forth, but there'll be the same amount of whitefish on both sides. All right, so eventually everything reaches equilibrium. So you have N2 plus 3H2 plus 2 ammonias. For this, I think it seems like the key is balancing the equation. So eventually you mix these two, nitrogen and hydrogen. The concentration, because initially all you have is nitrogen and hydrogen, the concentration of hydrogen and nitrogen go down while the concentration of NH3 goes up, but these never reach zero because NH3 is constantly going back to form nitrogen and hydrogen gas. And for example, probably a deeper AP Chem question, I haven't found a lot of hard questions on equilibrium, would be, that 3 there, so hydrogen concentration is going down the most. If you see that, it's going down 3 times as fast as nitrogen because there's only a 1 there. And this is increasing twice as fast as nitrogen. You kind of see that? Because, again, as Quincy said, never forget about the stoichiometry. 1 mole of nitrogen plus 3 moles of hydrogen, 2 moles of ammonia gas. All right, so this, get simple here. So concentrations reach levels where the rate of the forward reaction equals the rate of the reverse reaction. So that's kind of what I just said. All right. So here we go. So this is concept check 1. And again, you would ace this very quickly. So pay attention here. You would ace this very quickly. Again, these are questions on the test. Like multiple choice questions and essay questions that I look at and I'm like, gosh, this is something I should have used to teach at Marshall, something that they could understand. But consider an equilibrium mixture in a closed vessel, reacting according to the equation. So you have water, H2O, carbon monoxide, forms H2 plus CO2. If you add more H2O, so we're adding this to the flask, how does the concentration of each chemical compare to the original concentration after the equilibrium is reestablished? So if you're adding this, which way does the reaction increase? So one way that the AP Chem question goes is H2O is added, and I'm telling you, they're as simple as this. Where does the concentration, or where does the reaction increase? This way.
To the right.
Right. So if we add more H2O, H2 goes up, total H2 goes up, right? Total CO2 goes up, so that's easy to see. I also think it's decently easy to see that CO2 goes down.
Yeah.
Because now that we have more H2O, more CO2 is being used. Now the only, and I remember learning this, since I was a biochem major, we did a lot of this. And one thing that I had problems understanding is what happens to H2O. So remember, this reaction increases now this way. So now there's more products than reactants as before. So, for example, on your test, I'll go, well, how would each chemical, how would the concentration change? So how does the concentration of each change? These three seems easy, obvious. H2O would be initially higher, but since this reaction is now being forced this way, over time it's going to be lower than the initial concentration. Does that make sense?
Wait, could you repeat that?
So this is something, when I learned this, again, I understand it now, but at the time I didn't. I thought to myself, well, once it reached its former level, it'll go back to equilibrium. But this reaction now, adding H2O, is forcing this reaction this way. So more of this is being formed. When you add H2O originally, so on the next page it'll say that, originally it is, so the concentrations, each product will increase, we know that. The concentration of CO2 will decrease, we know that. The concentration of water will be higher than the original equilibrium, so it'll be higher at the beginning, we just added it, it's obviously higher, but lower than
What is the
original equilibrium. So it's higher than before you added it. And then once it reaches, then at the end, it's going to be lower because that reaction is now going favored one way.
Oh, is
So-
it gonna like switch the other way because you just added to the product?
Yes, because the products are now forming faster, so it's going to drop. So again, it's at equilibrium, you add one reactant. Initially it's higher, but since it's going towards the products, so initially higher. So it's, and the way the AP Chem test is, asked is, and it doesn't make sense until you really think about it. You add H2O, what happens to the concentration of H2O once it reaches equilibrium? It's lower because the reaction is this way. Does that make some sense? So that's higher, that's lower, even though you're adding that. Initially it's higher, but once it reaches equilibrium, because this reaction is going forward and backwards, it's now favored this way, so the concentration of H2O would be lower. Does that make sense a little bit? So I remember going, I always understood this, and going like, what? Like how could it be lower? It doesn't even actually make sense until you see that initially the reaction, a certain amount is going this way, a certain amount is going this way. You add more of this, the reaction is favored this way, and over time, since the reaction is favored this way, you're going to end up with less H2O being formed because more products being formed here. Make some sense? So that's really the only hard part of it. I think the other three you understand. And you will see questions on the AP test that really are pretty simple. Like which way is a reaction favored if you, so like for the next question, consider equilibrium mixture in a closed vessel reacting blah, blah, blah. You add H2. You know, every night I try to just read through AP questions before I fall asleep just for like 5-10 minutes. And this question's like which way would the reaction be favored? Towards the left or towards the right? And it actually says towards the left or towards the right. So it would be favored this way. So you add more H2O. How does the concentration of each chemical compare to its original concentration after equilibrium is established? So this is going to be what? If I add this,
Goes down.
that's going to go down because more of this is forming those two. So that's up, and the way that the question asks it, and this is how the AP Chem questions ask it, and it is, I have seen them in short answer, is it seems crazy, but H2 goes down. It seems weird, and I never grasped it when I was in biochem. What's that? But it says that, but it says after equilibrium, right. Right, initially, initially it's higher, and when I was in biochem and we did tons of this, it was like, didn't make sense to me that the final answer would be it goes down in concentration. Like it doesn't make any sense, but it does now, just think of the way it's favored, yeah.
Is that like similar to single replacement thing?
Yeah, so I mean that's something that we haven't done, that maybe for the spring break review. So this would be single replacement reaction. So H2O plus carbon, because that's not CO2. So yeah, people who didn't have chemistry last year wouldn't know single replacement. But that O is going there. And since I'm taping it, we won't make the dating analogies, which worked very well. So yeah, that's something that you guys would understand like this, and that we haven't gone over, that will be on the test. All right, so first two, all right, this is opposite scenario, previous slide, the concentration of water and O2 will increase. So that's something, easy 10 points for you guys, right? All right, so it doesn't get much harder here. So now this is K, this is not kinetics, this is equilibrium. And they'll be specific on the test if it's kinetics or equilibrium. And this is always the equation for it. And you're going to see that the ones you're going to get on the test Friday, like, just plug stuff in. So C, it's products over reactants. C to the L, D to the M, raised to that, A raised to that, B raised to the coefficient. So you'll see right here. So remember, this is different than kinetics, so this is something I wrote in myself. Something I repeated a couple times. All right, I moved a slide because I thought it would be more important later, but let's go back to this. The socially aware fish. So if I increased heat, would this change? Maybe the fish would swim faster. So in chemistry, the molecules move faster, but this equilibrium will be the same, right? If I increased the same amount of concentration on both sides, the equilibrium would be the same. The only thing that changes these, they've found that changes the equilibrium, is pressure. So if I put pressure on this, if I force this pressure, and then this water went up more, then there'll be less fish over here than over here. So the only thing that changes equilibrium is pressure.
So if there isn't the same amount of water, you should change it.
Yeah, essentially, yeah. So if I increase, so if you have two cylinders and the reaction's going back and forth, if I increase pressure on one cylinder, there's going to be far more reactants or far more products, whichever side I didn't increase the pressure in. So the only thing that matters is pressure in equilibrium. And again, that seems to be the hardest thing. And I did research because I really want you guys to do well. I researched it. I couldn't find anything that was harder than pressure and equilibrium on it, other than graphs like this, which what would be the most likely coefficient ratio between H2 and NH3 based on the graph.
So you just be like 3-1.
Yeah, so you would look at this, and the answers are somewhat obvious. You see that this is slightly more than that, but not much more. So you would say, 3-2 for if you were going H2 to NH3. So they would give you a graph like that, and you would have to just eye that out. And they seem more obvious than this one does. So that took a little bit to understand what they were saying. All right. So anyways, so essay 2 would simply be write
Please pardon the interruption. Calvin Watson reports to the main office. Calvin Watson.
K coefficient, the equilibrium coefficient for this reaction. As simple as K products NH3, you have a 2 there, that goes there, N2, 1, so nothing, H2, 3 there. Simple enough? Right. So, right. So now that P would be, and they give you the pressure of put on the system. So, including pressure. So this is why, I probably read over it at Marshall at the time, and being like, although they understood pressure, this would be pressure plays a role. So the pressure on the reactant side over the pressure on the product side, because that plays a role at ATM. So it's at ATM. So something that I saw on there, which is what it is they give you like torr, and you have to then convert it to ATM. Yeah, so but again, you get those conversions on the test. It's just that they try to trick you in everywhere possible. But this stuff, I think you guys, it always has to be an ATM, right? And this is the other way that they try to trick you, is equilibrium expression for the reverse reaction is the reciprocal for that of the reaction written in reverse. So K values are usually written without units. So no units, Quincy. So here, what's that saying is simply we got N2 plus 3H2 equals 2NH3. And they go, on the AP Chem test, they go, write the equilibrium K value for the reciprocal of this. Keep in mind this is like this. We always go left to right, but the reciprocal would be opposite. So this is simply K, so what they're doing is looking for the opposite. K minus 1 is now, those are the products. And these are the reactants. So, and they want it written like that, K minus 1. So the reciprocal this way. Does that make some sense? So it's nothing too hard. I should have made this an essay question. So I probably will. Because it makes sense, because essentially why are these the reactants and this is the product? Since the reaction is going back and forth, it's a matter of opinion, essentially. But since we write it like this, K initial would be like we did before, or K regular would be like we did before, and then K minus 1, the reciprocal would be just backwards. All right, make sense? So I should make this like, because again, I saw it, what is today? I saw it Sunday night. I should make this an essay, because again, it's essay something, I don't know. Because it's, I don't know, it's something you understand. It's something asked on the test that if you don't know, seems like something that's hard where it really isn't. K always has the same value at a given temperature regardless of the amounts of reactants and products that are present. So we just talked about that. K involves concentrations. Kp involves pressure. Unlike temp and total amount, pressure always plays a role. All right, so this will be SA3. And this is something that, again, after an explanation right now, you'd ace. So equilibrium pressures at certain temperatures. So you would just simply, you have, so K equals NH, so NH3 2.9 times 10 to the negative second, 2 over N2 8.9 times 10 to the negative first, and 2.9 times 10 to the negative 3 raised to the third. So then you would just calculate that. The only thing that, looking at not as much your test, but third hour tests, they're not good at order of operations. Meaning, like, they would have to solve this first. Like, you can't just type all that in a straight line, unless if you use parentheses, if you're really good at using parentheses. So you have to solve the powers first, and then solve from there. Does that make sense? So, I don't know what I'm going to do with scientific calculators. Like, we'll have enough for the test because you can borrow them from people, but like before the test we have to, so maybe those 2 weeks, something over Easter, I'll figure out how to get us scientific calculators. I'll buy them and then sell them. Right, so, okay, so essentially that's what they did. And so the Kp, so I wrote that wrong. So that would be Kp, K with that pressure, compared to just K, would be that answer. So that should say SA3. So nothing too tough, and it doesn't get any hard. The only tricks that I saw was Kp minus 1, or if they didn't put in ATM. That's the only, right. Right. And then I saw one from 4 years ago or something like that where they put 2 in ATM and 1 in TOR, and they're just trying to trick you. And then it doesn't have units. All right. So far, again, I think those 3, I'm not going to, since we're going to go fast, I'm not going to try to trick you either. And I'm not finding too many trick questions on the AP test, but okay. So a value of K is much larger than 1 means that the equilibrium of the reaction system will consist mostly of products. The equilibrium lies to the right. So this will make sense. So if
Pardon the
you,
interruption, Ms. Went. You called the main office.
if you have
Ms. Went.
this reaction here, oh no, the eraser one. Eraser. So if you have this reaction, and this is a large number, so we're looking at concentration. This is a large number, and this is a small number. That number is going to be big when you figure out K, right?
Yeah.
So if this number is larger than 1, the reaction is favored this way. Does that make sense? If it's smaller than 1, the reaction's favored this way, because that means this is going to be a small number, and that's a large number. So a very small number of K means the system at equilibrium will consist mostly of reactants. The equilibrium position is far to the left. So I can't really think of an example of that. I did third hour, but it might be wrong, so now I don't want to say it. So anyway, so concept 4, the equilibrium to the right, what's a K value? So all I'm going to do, pretty much, I can't.
More than 1.
Yeah, so I can't change that. So that's easy 10 points again, right? So if it's to the left, if the equilibrium lies to the right, the K value is higher than 1. And then it's lower than 1 if it's to the left. Alright, so that makes sense? So that's easy 10 points. So far, I think so we're almost done with half the test, and it's easy. Used when all the initial concentrations are non-zero. Okay, so we're not going to go through this yet. Yeah, but the only thing that seemed to be tough would be they always on the test with these equilibrium ones, they don't give you balance equations. So like, yeah, so 1, 2, 3, and once you do that, and they actually give you this on the test, on your formula sheet. They give you, not that it's incredibly hard to remember, but they give you, but like all the later questions, it's a matter of just plugging stuff into this equation. And they give that to you on the AP test. Not that it's almost like they give you some of the easier stuff to remember. But all those later questions, it's simply plugging stuff in to this equation or to the pressure equation, if it has to do with pressure. So after tomorrow, you guys could probably ace this test if there was not anything else on that test that I saw that was hard. All right, sound good? So hope this has been taken.